the left, right? There it is. Hi, Joe.
That's cool. Awesome.
Watson, come in here. I think we've got established contact. It's the weekly vlog podcast, ladies and gentlemen, for our beloved Santa Barbara Astronomical Unit. We call SBAU Astro Hour. It's episode 84. It's over a year and a half. For the week of October 3rd through the 9th. That's Monday the 3rd today till next Sunday the 9th. We're live from our computer dens and man caves every Monday morning, 11 a.m. And we like to talk about new discoveries and happenings in space with launches and planets and galaxies and even a variable star if we get to it today. You're welcome to comment on YouTube with a 20-second delay. You'll get most of it. We have a special guest we're going to introduce you to in a minute. Let me get to, my name is Ron Herron. I'm the proud vice president of the club, several years, up for re-election along with President Jerry Wilson in December. Hello, Jerry.
Good morning.
It's either him or the man to my right on the screen, Tom Totten, who is a webmaster. Between them, we got it covered on Zoom and everything but webinar. Let me introduce you to ChuckMcP, our incredible outreach coordinator, and a former Westmont College instructor who they all miss, Tom Whittemore, edits our newsletter. Tom is on board. And I guess we won't have Bruce Murdoch today, but I would like to introduce you to a young man who's going to be catching us up to date on a NASA launch of a year ago, which has got kind of an interesting turn of events as it heads to Jupiter of all places. But it's coming by here. Levi Parillo, NASA ambassador. And I'll let you tell us the work, the rest that you do down out there in Goleta. And you're also on your way to a doctorate in astronomy. Levi, good morning. Thanks.
Good morning. I wish I was on my way to a doctorate. I'm not that smart yet. I'm on my way to finishing my bachelor's in electrical engineering.
Okay, but you got in touch with us. You said your wife had heard about our club.
Yes, sir.
And as a NASA ambassador, which also Chrissy Cook, one of the lady that at the museum, one of our members, you met her, I guess, or talked to her, and she gave you my number. And thank you for getting in touch with us. We're going to start with Levi. He has an update on the Lucy mission. What is Lucy and when did it take off, Levi?
Well, Lucy is probably the first ever of its kind, but won't be the last, of a satellite that has been launched on October 16th last year, so 2021. And it is going to be visiting now 11. It was originally going to be about 8 to 9, but they decided to tack on 2 more asteroids, which I'll talk about as we go on, to collect samples and basically more data from these 11 asteroids that have been traced back to the Big Bang.
Wow. Okay. Well, why are you knowledgeable about this?
Well, I'm knowledgeable on this only because I was blessed with the opportunity to be a intern on the National Proposal Writing Ship for NASA starting last year. And it just so happened that they were starting to get people for the Lucy mission. So I kind of snuck on board during that time. And it's been a fun time ever since. Been involved with NASA internships, various ones, for a little over a year now.
Okay. Do you mind if the board and myself ask questions during your talk? Jerry, Chuck, and the 2 Toms?
No, you guys are all welcome. Anybody's welcome to ask questions. I just need permission to share screen so I can show you guys all the pretty pictures that I got that go along with the presentation.
Any comments or questions before he starts, guys? There's a cat that wants to talk too from Chuck. Well, take off. Well, let's find out what Lucy said.
You should be able to share screen now.
All right, I'm getting it going right now. Let's see. All right, so here we go. Hopefully. Come on. There we are. So Lucy is a little skeleton right here. That is how the name actually began. Lucy is the oldest so far fossil that has been found of the human species. That dates back over 600,000 years ago that they managed to find the oldest living person so far. And they named her Lucy after one of the investigators that was leading the archaeological dig. And they figured what better way to name the mission that is going to discover the origins of the universe through these asteroids after the oldest person so far. So seems like it'd be a great name for it. So here's where we are in this beautiful sun, you got your whole solar system set up here. It's going to be a little bit of a infographic, so it'll move as we go along. And as we zoom out here, you can kind of see the rotation and where we're going to be headed. This is the lovely asteroid and debris field all over the place that we're going to have Lucy navigate through. So right back down here is right where we're located. Like I said, these 11 asteroids are going to be basically the fossils of the solar system. They're the oldest living records that we know of currently. So as I got ahead of myself here with it, the human ancestor fossil found in Ethiopia, that's how it was named, via Lucy. And so the main asteroid belts, as you can see, is kind of clustered right around here, but we're interested is on these edges in Jupiter's direct orbit, as you can tell. And Earth is right over here.
Wow.
So as you know, just a little quick backstory, you got your four basic planets, you got the rocks, the gas giants. So these asteroids are actually quite interesting enough that they are mixed with different compositions of all 8, if you count Pluto, 9 planets and their composition origins. So it is quite a very interesting group of asteroids to study, because it's got honestly some of the best information that we didn't first know existed, but it's kind of close enough for us to get out there to go see. So it'll basically help us get, some of the rock compositions, some of the ice materials. Some of them are being picked up with traces of water, which is why we decided to send out to it in the form of ice. Basically, we'll also find out what planets that they represent, what are their compositions, and what materials are needed for life, on Earth from these asteroids. Some of these asteroids are also believed to hold what's called alien or X materials that are just straight up unknown compositions that we have never yet seen or discovered before. So as I say, it's a road trip. It's a very long road trip out to Jupiter to do this. It's going to involve 2 EGA assists off the moon.
Wow.
That is the current speed. If you were to give Lucy a speedometer, it is currently traveling at 96,720 miles per hour.
Wow.
Has that already had a couple of gravity assists?
No, that's what makes October 16th, next Saturday and Sunday, so special, and I'll get to that.
Okay.
So this is the Lucy spacecraft. If you're unfamiliar with it, it's about 50 feet long. The main piece here is about the size of your standard Honda Civic. So it's not that big, but it's got a lot of information kind of packed into those little areas. This whole thing is big solar arrays. I'm sure you guys were aware back when it launched that it had issues actually deploying one of the solar arrays fully. It happened to be this one on the right, and it was this patch right here that they're having trouble completely expanding like the one on the left is.
Huh. So they didn't get that fixed?
They slowly did over time. A lot of just kind of just pressing a little bit, letting it do its own thing. Just over time, they just were slowly sending signals to it, just like letting it sit, send a command, keep pulling it in, let it sit, set a command. So now it's about 99% fully deployed on the right side here. The left side's 100% totally fine. This gap is very hard to distinguish right now. What happened was there's a lanyard here, and I'll show in one of the slides ahead that there's this piece that it kind of got jammed on the when it was being coiled up, and it didn't fully get unhooked. So they didn't catch that before it was all packed up and sent away. That's what caused the solar array anomaly, as I call it.
And they didn't put a dummy in the car seat there, did they?
No, but they did put Dr. Hall Levinson in the car. So.
So this is the answer to Elon Musk's sports car.
It is. This is exactly it. So
caused 2 of our members to go buy Teslas.
That's too funny.
Interesting. Fascinating.
Here's the solar array.
It's not going to crash, though. This is not a crashing into an asteroid.
No, think of it as the old video game Frogger. It's going to hop along each asteroid.
9, 6, 8, 0, 0, 3, 5.
So this is the solar array in one of Lockheed's labs. As you can see, all of these black dots are photosensitive and photoconductive devices. So each one of these powers up basically the satellite, and it Basically, all of this power goes through, and this rod here helps feed it towards the satellite.
Huh.
You know, it looks like one of those arrays was curled or curved a little bit. Are these flexible solar cells?
Yes, they are flexible to an extent. As you can see here, you can kind of see that curved pattern, especially on the arrays closest to your field of view here.
Uh-huh.
They kind of are bent at about I believe it's about a 40-ish degree angle, somewhere around there. I have to double check the angle measurement,
Okay.
but they are bent. They are kind of concave looking if you were to look at them
Okay.
head on.
Hmm.
And so as you can kind of see, ironically enough, here's that panel. And it's hard to see here, but this is that lanyard that's going across this thin string that's up against it. That's the panel that they had issues with. So here's the vertical assembly building. As you can see, this is the base of the satellite and the base of the rocket going to be built. This is the Lucy logo kind of stamped on right there with Lockheed. And this is the whole capsule that delivered Lucy over on its way to Florida at Cape Canaveral. Now, these were the photos that I was able to take and I put into the presentation. They were the clearest looking images. So on the left, on this side, is the rocket just after liftoff. You can see the smoke and the exhaust here coming across the island. And that big burning ball is the rocket. This took off at, I believe the timestamp was 5:32 a.m., 5:31 a.m. in that time frame. And it was a beautiful morning to take off. The middle image was something quite interesting, is that as it was going through some of the clouds, it was actually sucking in the moisture from the clouds into the rocket engine, and it was making this spiral out of the clouds as it went through. It was quite an interesting show to see that. And this is an awesome time lapse that we were able to put together with some other people that were there of the photo of the rocket launch as it left our viewing. So one of the questions I always get, and I got this last time, I'll probably preempt it, is that everyone asks, well, why is it curved? Why isn't it a straight shot like an arrow? Well, that's just following the general curve of the Earth's atmosphere as it goes, but also it uses a little bit of centripetal force as it goes up through the atmosphere to go through that very specific window that they're looking for, because they can't just launch it straight up in the air for it to go into a specific spot. It has to hit a very specific window that minimizes damage to the rocket on its exit, minimizes resistance, and makes it a little bit easier for NASA to track.
Well, forgive me, but where has it been for a year if it's going to Jupiter?
So Lucy, right here on the 21st of October, here's the rocket. It is taking a very wide launch around Earth to get itself into position of the EGA, which is happening October 15th, October 16th of this year at 4:04 a.m. So it took a very, very wide loop to basically get into this specific position, because it's going to do 2 slingshots off of the moon.
What's EGA?
EGA is Earth Gravity Assist.
Okay.
So it's going to play on the 2 fields of the moon's gravity field and the Earth's gravity field, and allow it to wrap around and slingshot it to get farther out of Earth's gravitational field.
Did we get a question from Tim Crawford?
I believe so. How
I
much of a
saw it appear on the
determinant?
screen.
Oh, yes, I got it. How much of a detriment is a 99% deployment on one of the solar panels? Well, the last update that I got from them, which was about a month ago, is that it is 0.001% detriment. Everything is functioning on the aircraft as expected. They are not having any problems as of note.
Did you get a question from Tim Crawford?
Yeah, you got that.
How
I
much
saw
of a
it appear on
detriment?
the screen.
Oh, yes, I got it. How much of a detriment is a 99% deployment on one of the solar panels? Well, the last update that I got from them, which was about a month ago.
We're getting into a loop here.
I know, I'm trying to shut the audio
everything is
off
functioning
here.
on the aircraft as
Oh, Bruce. Morning,
Right.
Bruce.
Good morning.
Welcome to the Truman Show.
Good. I was worried it was me with the loop. Okay.
No, you've got a working power supply.
Oh, welcome aboard, Bruce Murdoch,
Thank you.
our Theater Organ Society
Yeah.
guy. Bruce, meet Levi Parillo. He's giving us a guided tour of the Lucy mission that was launched a year ago, and it's about to swing by the Earth and the Moon, right?
Yes,
Okay.
sir.
Levi, you can continue.
Yeah, I was watching the live stream. I was having difficulty getting signed in.
Okay,
Okay.
welcome.
So yes, it'll do an EGA soon, which is why NASA has been adamant about us getting out and about and talking about the Lucy mission. It's going to be swinging by October 16th, 404. And the reason why everyone is trying to, or NASA is trying especially to get this out, it'll be low enough in coming by Earth that you will actually not need a telescope. You'll be able to see it with a pair of binoculars if you spot it.
Wow.
And that's quite an interesting note. Its trajectory will be 10 kilometers below the ISS's current orbit. So it'll actually be a little bit lower than the ISS. So that's part of the reason why you'll be able to catch it with binoculars.
So it won't be visible from everywhere on Earth, just from right under the path.
Yes, directly under the path. Luckily for us on the West Coast, we have a 99% viewing chance. So we should be able to see it.
Okay.
Wow.
But yes, so it'll come by. Technically, it starts October 15th, which is why we noted October 22, October 15th. Is it technically starts its EGA around 11 to 11:59 p.m. to begin the EGA assist. So it'll take a couple hours for it to swing all the way around the dark side of the moon and come back around. But once it reaches viewing areas, it'll be about 4:04 a.m. I would say you want to be out there standing around there around 4 o'clock in the morning, a little sooner in case Lucy gets a extra speed boost and goes a little bit faster by.
So it's already doing 95,000 miles an hour. How much faster is it going to be going after the Earth?
I believe what they stated was tentative measurements will be a little bit closer to 115,000 miles per hour. But it's not exact because depending on how well the EGA goes, it'll determine its final speed, its terminal.
Okay.
But expected is to give it a boost of about 30,000 miles per hour, so that way it can sling out of that intermediate Earth orbit to go out into the trailing edges orbits. Basically, it's going to aim to reach around here before it swings back by again.
It's coming back?
Yes, it'll come back twice. It'll be one more time. It comes back in 2024, I believe. I'll confirm myself in a couple seconds.
Wow. We haven't had to do that with other probes out to the Cassini and other, Juno. They just went right there. Why? How does this one differ?
That's not true, Ron. We've done flybys with those.
Have we? Around the Earth.
Around the Earth and around Venus.
Yeah. Mars, we send them directly, but it takes a long time.
Oh, okay.
And part of it is that also there's two test asteroids along the way, and they're a little bit closer. So that's part of the reason why they're doing the second EGA is we're going to catch those guys on the way by with the second EGA.
So you're going to do a flyby on them?
Yes, we'll do a little bit of a flyby by these guys to make sure the first one will be confirming the first set of instruments, which will be the temperature gauge and basically materials acquisition to see if it can actually lock on to an asteroid to pick a spot for us to make an inset. And the second one will be more confirming if we can get kind of more of a final, dress rehearsal to see if it can actually get compositions off of it, get the correct imaging, and get us something that we can read and understand coming back to us.
Okay. Good.
The 5,000 or so satellites we have there, plus all the space junk, when you come into that low orbit around the Earth, is there any concern that you're going to hit something?
That is always a concern. They believe with the orbit that they are aiming Lucy to be on from its first EGA is the path of least resistance. So it should be the, quote, as they say, cleanest orbit that they're going to be running through. There is the possibility of running into space junk. That's always a possibility with anything headed up into any orbit, especially low Earth orbit. But this is something they believe that the orbit trajectory that they're being sent on should be the cleanest run for them.
Yeah, so they are looking at that.
Oh, heavily. It is actually one of NASA's biggest pain points of how to either A, eliminate space junk, or B, basically make a giant space garbage disposal system out there too.
And after 4 p.m.
rocket propellant that they can move the satellite a little bit one way or the other?
Yes, on the satellite itself, there's a couple auxiliary powers on the left and right side to help kind of give it those little puffs of air, like you kind of see on the ISS, where it gives it the little push of thrust to go left or right if it needs to.
And
It has a
coming up
couple of
this
those.
afternoon, a little before 4 o'clock, there's going to be another load of space junk from SpaceX going up from Vandenberg.
That's going to be probably one of our biggest problems in the time to come.
But they can't get that Artemis 1 off the pad in Canaveral to save their lives, can they?
No, they cannot. Ironically enough, since you brought up space junk, I'll give you a little tidbit from my first internship. We are one of the things NASA is actually making and looking to create are CubeSats that specifically are designed just to go out and scoop up space debris and space junk. So it's kind of, they're going to turn into little space garbage men and go around and help collect some stuff.
Well, Levi, can you explain these curves on the screen that I'm watching? The red is the probe, right? The Lucy,
Yes.
and the blue is our orbit, and the
Yes.
little yellow. Okay.
So this is Lucy. I'll go back a little bit so you can kind of see it as it goes through. I'm talking about the second EGA. You'll see right here, right around Christmas time in 2024 is when it'll do the second EGA launch. And as I was saying, there's that asteroid that it's going to do its first test run on. That's part of the reason why we're launching it so far out, is it's going to get in line with this guy on the way for its second EGA and come perfect within orbit of this one on its way out. So that is the need of the second EGA, because it gives us a perfect opportunity to kind of co-line up the orbits as it goes through to see if it can go side by side with an asteroid.
Huh. This will be the Trojan belt of Jupiter's orbit.
Not this
No,
one.
not
This,
yet.
this is
Oh, this really?
Yes, this is a close one. This is test number 1.
Oh, I see. God,
They're going to be out this way. The other ones you're referring to, the Trojans, are way out here because there's Jupiter up there.
Levi, is there a speed boost going next to the Earth, EGAs, or is it just a redirection?
It's a speed boost. So it's breaking out of different levels of Earth's gravity fields because of its different orbits. So the second one will allow it to basically slingshot out, catch this guy, and then keep going to get in basically in line, so to speak, and swing around, getting closer to Jupiter's field.
And it'll arrive when?
I will get to that.
Oh,
No worries.
More
Do you
to
have
the
any idea
story.
how much? Do you have any idea what the speed boost will be?
For the second EGA,
First or second? Yeah.
first or second, the first one, it is tentatively supposed to be around 25 to 30,000, but it depends on how well the EGA actually goes, how tight they can make that angular return coming back around the other side of the moon. So it's not a definite number yet, but it is some estimation. They'll get a better idea of the terminal velocity once they kind of begin to swing back around from the dark side of the moon and reestablish communication.
Thank you.
But it's going to go all the way around the moon and come back. Wow.
Yes.
I thought they were just light angled ellipses.
It's
No.
gonna pass behind the moon and boost that way. It's not gonna swing real tightly around the moon.
Oh, okay.
It's not gonna
Exactly.
orbit the moon.
Well, it's going to get more gravity assist from the Earth, I assume, than from the moon.
Probably a little more.
Yes, it's taking advantage of both, because on the backside as it comes around, it'll start to clip the small field that the moon has. Like it's its first initial boost, and then when it starts to catch that, it'll be into Earth's gravity assist. That's when it'll start to really speed up,
I got you.
which is why it's hard for us to put a very specific number on how fast it'll start going.
Wow.
So here's our first unexplored main belt. That's the one we were talking about, our test one from Dr. Donald Johnson. That's our first one coming off EGA 1. It'll try to intercept it on its way out to come around into EGA 2. So it's expecting by 2025 that it should make contact with this first test asteroid. So almost 3 years later, it's going to make its first attempt.
Huh. His name is probably Johansson.
Johansson, most likely, yes, probably Johansson.
Yeah. Okay. Wow. We're not
So
going
this
to.
one,
We're not going to do a gravity assist around him, though.
no.
Okay,
He's our test guy. He's going to come through, and on our way from our second EGA, he's the one that you saw in the first one right here. He's floating right there.
Tom Whittemore, you got any questions?
No, not now. Thanks.
Okay, anytime. Go ahead.
So here's Euripides. I apologize. I'll probably butcher some of these. My Greek is not the strongest. So it'll begin its flyby August 12th, 2027. So 5 years from now, we'll make it finally to the first Trojan asteroid as we get in line at the traffic jam of the asteroids out here. This one will be our first true data collection point for the Lucy mission, as it is the first survivor from the Big Bang and the collision that created some of the planets.
Do you know what type of asteroid it is and how big it is? Roughly?
Not quite sure. I'm not quite sure on both the type of asteroid and its composition, but it's most likely going to be more of the rocky ice style asteroids.
Is that an actual picture of it, or is that just an illustration?
It is a picture with a little bit of illustration / rendition behind it, but this was from one of NASA's images of the asteroid, the best way they can make it look.
Okay.
Actually, Wikipedia says that it's a carbonaceous Jupiter Trojan.
Okay, looks round.
About 68 kilometers in diameter.
Okay.
Nice.
So
And that image there is just an artist's rendition. That's not an actual image. We don't have any of it.
Right.
Okay, so we don't know that it's spherical, that it actually has got enough gravity to form a sphere.
Well, there have been some occultations of it, so we have some idea, but it's probably not a perfect sphere.
Do we know if there's any dwarf planets in the Trojans?
Ron, dwarf planet definition is it orbits the sun, so it wouldn't be.
Well, no, but Vesta is a dwarf planet, isn't it?
But it's an asteroid in the main belt. It doesn't orbit. It's not in a Jupiter Trojan orbit.
Yeah.
Oh, well, it orbits the sun just like, okay.
Not on its own.
Not on its own?
Yeah, no, it's being tugged along by Jupiter.
Yep.
Okay, well, my understanding was that when a rock gets so big, 300 or 400 miles across, it's got to be spherical.
Like, it depends what it's made out of.
And there aren't. I just wondered if there were any that big in the Trojans.
There may well be, depending what they're made out of. It's a carbonaceous chondrite. It's not going to be a really strong structure.
Yeah.
Okay.
Okay, let's let Levi get back to his talk.
No, I do appreciate the supplemental information. So I definitely appreciate that. So it adds more discussion, which is always great because it adds to the education. So this is the extra one, which is Queta. I hope I pronounced that one right. It is a small asteroid kind of near Euripides. So this is kind of the +1 that they've added to the original mission list. Next one is the smallest and the tiniest of the grouping, which is Polymele. And this one will be September 15th, 2027. So about a 2-year gap after the first asteroid has been visited.
Another artist rendering.
Yes. A lot of them are artist renderings because, as you can tell, some of the images that we have look something like that. So
I can see that.
As long as it's not coming at us, I'm fine with it.
Exactly. But hopefully DART will be successful in sending anything else the opposite way if it comes this way.
Yeah.
They said they discovered a moon that goes around Polymele.
Yes.
Really? Wow.
It's about 3 miles in diameter.
Well, then why don't we crash into it?
We're out of crashers right now.
Oh, we are. Okay.
All right. So continuing on, the little satellite, and I believe this is what you're referring to. We didn't get that update about it, but I believe it's that little moon that you were just talking about.
Yeah.
That it's following along. So they added that along. They discovered that recently to investigate as well, since it's kind of tugging along with it.
That's an occultation track there, where you have a group of people lined up along the shadow path as it passes in front of a star, and timing the disappearances of the star.
Yes.
The round thing is the asteroid. What are the lines?
The lines are where people were lined up along its shadow path with their telescopes.
They made a video of the star as the asteroid passed.
That's what Chuck does.
Yeah.
Very accurate time-stamped video.
You missed that one, McPartland?
I wasn't in the shadow path.
Oh,
Okay.
gotcha. It makes sense. Shaped like an egg.
Yeah,
You can't tell. It could be rotating at the time. It's not a clean horizon measurement.
But all we're going to do out there is look at them, orbit them, go from 1 to 1, just stay in. Are we going to leave the probe there as one of the new asteroids in the Trojan belt?
probe won't stay there. We're gonna go one by one by one by one.
We're just going to take data.
Yes,
And-
data
and come-
collection.
And come back.
Yes,
Are you going to use gravity assist, or do you have to use rocket fuel to go around?
it'll be a little bit of fuel.
Wow.
So it'll be a little bit of fuel. Most of the fuel will be for the return trip, but part of it will also be used for the gravity assist coming with it in Jupiter's gravitational field.
Wow. And this whole program is named after an ancient pile of bones from Ethiopia.
Yes. Looks like we have another question in the chat.
Okay.
I may have missed this, but how exactly does Lucy sample the composition of the asteroids? We are going to get to that. I will be talking about the instruments shortly.
Good.
So as we continue, third asteroid, this one is the potato. Lucis or Lucas. Again, my pronunciations are going to be botched with my Greek. I
Your
apologize.
guess is as good as mine.
Well, that's good. This will be April 18th, 2028. So again, quite a big difference. About another year later, it'll make it to the third asteroid to get sampled. And you can kind of see Lucy down here with these asteroids along the way here. So you can kind of get a guess where it's heading next. Oris is in the same field. It's going to catch him on its way back down as it descends back into Jupiter's more direct orbital path. This one's the reddest, meaning and from composition tell that we can see. November 11th, 2028 is when it's expected to reach Oris.
Long time.
Huh.
Now, things that get red in space, exposed to space, I know Oumuamua was supposed to be red, and this is written up as the reddest Trojan target. What makes us an object susceptible to turning red? Do you know that, or is that a certain composition, or is that what we're waiting to see?
Well, from my understanding so far is that it's a little bit of both. It's a wait to see. We're not quite sure because as you stated earlier, just a moment ago, that sometimes we deem something as red and we're not quite sure. Then we get an image of it and well, it's actually not red. It's more orange or yellow. And so we're trying to get an understanding of it. But part of it is believed to be the material composition of the asteroid itself, is that it's got something in it. Because it would make sense, logically speaking, that this would be the reddest because between Mars and Jupiter, they're both kind of reddish orange hued planets, red. So it would make sense that this one has some material that is from one of the red giants out there.
The more weathered they are from things like the solar wind bombardment and from ultraviolet radiation, the redder they tend to be. It seems to be a weathering effect on any organic compounds they have. So that's a hint of looking for organic things too.
Yes, exactly. You beat me to my next piece. I was going to talk about the heat from it is another capability. So I love the fact that talking with experts like you guys are about some of this stuff is really good because it adds to the people also listening some double information. So I definitely appreciate you guys jumping in.
Well, doesn't the element iron figure into the red anywhere?
Only if it's got a lot of oxygen.
That's why Mars is red.
Yeah.
Oh, it is. Okay.
As you see, we can slow any talk down. Let's let them get back to it.
So here's our third EGA. So yes, I kept this quiet. I was just trying to, so I didn't speak ahead of the slides that were coming. It'll do one more EGA on Christmas Day of 2030 to swing out to the last set of asteroids.
Wow. 8 years away.
There are two sets of Trojan asteroids, one leading Jupiter and one following Jupiter. So that's why we have to pop back in to be able to get out to the other set.
Yep, that's exactly it. It's just conservation of fuel efforts. Since it's wanting to save most of its fuel for the return trip, the EGAs are the best way forward for us to basically fly for free.
Return trip, does that mean coming back to Earth?
Yes.
Why?
after we get the last sample.
Sample, but it's all data sample. You're not bringing any particles back.
So that was the one thing that's kind of been for a little bit of a discussion is I believe, and I definitely can be wrong, is that they're going to try to take an actual sample as well
Okay.
and try to carry it back with them. A lot of it's going to be data driven from scientific instruments, which I'll talk about here in a little bit. But
Okay.
they are going, there's been talk about trying to see if they can on the last asteroid to make a snag and grab. And
Well, we'll have you back for a follow-up talk on each of these EGAs.
that sounds great. I know NASA will be pushing for them as they come through.
Yeah.
Meanwhile, for many years, it's going to orbit the sun just like the Earth does.
Yes, exactly.
And the orbits will be almost about a year, or is it further out and slower, or 2 years, 3 years? Where does it go?
It's a year to 2 years following the orbital path to get to the asteroids. So as you can see, it's going to take 3 years from its last EGA assist to get all the way back out to the last 2 asteroids.
Okay.
So we got
Wow,
Patrick.
quite a tour.
Yes, that's what makes Lucy so talked about, as it's quite a endeavor and a marathon of a mission.
Yeah.
You want to pronounce these 2 asteroids for us?
So we got Patroclus and Menonitis of the last 2 asteroids. These 2 are quite interesting. They are basically super neighbors to each other, and I'll explain that in a second. But I thought I had the image. I might not. I was trying to get it into the presentation. But these 2 asteroids are so close. If you were to stand on it and had your friend stand on the other, you could actually see each other and wave to each other. They're that close. These asteroids are pretty close together.
Yeah, it's a binary system. They're orbiting a common center of mass, and I've gotten occultations on these before.
Huh.
Wow.
Very nice.
Yes. So there's a possibility they're thinking that, it's, as you said, it's a binary system as they come together with it. But there's a possibility that one of the theories / hypotheses is that this might have been an original mass and over time it split, which is why they're wanting to study both of them.
Wow.
So now to the scientific instruments on board. Easiest one here is the high gain antenna. This is what will be transmitting a lot of the data back towards Earth. You got LaRalph, the two T2 cam, Lattice, and the Lori cameras. Lori camera.
What does the L stand for? Lucy?
Yes, as part of the Lucy, it's also a French designation.
Okay, it's French. Okay, good.
Looks French.
So the Lori camera will be, as you've seen, a New Horizons spacecraft that used Pluto's moon, Herron, however you may pronounce it. This will get us the geological aspect of it. So dense crater impacts, anything like that on the asteroid surfaces. That's going to be what the Lori does, and takes all of the high definition photos to understand the geographical landscape of the asteroids as we go by.
So what size is a pixel in terms of the dimension on the asteroid itself?
That I do not have the
50
answer.
feet, 1,000 feet.
That's going to depend on how close they come.
Yes.
I know. They must be aiming for some particular number though.
That information has not been disclosed, at least for general public.
Yeah, I think there's so much gravitational assist and travel that trying to put an exact number on it at this time, I think might be a little premature.
You can see that photo that's there. It shows 50 kilometers there, that you might be able to kind of estimate what a pixel might be.
Yeah.
Well, what are we looking at? An asteroid surface?
Pluto's moon.
Charon. Oh, you
Herron.
This is from the New Horizons mission.
really got that close.
They're reusing instruments from some previous missions like the TES and the Lori, and then they added the L on front for Lucy.
Yeah, it's classic risk mitigation.
Yes. Specifically because they know it works. If it's not broke, don't fix it.
Right.
Well, are there 2 parts to the Trojan belt? One on one Lagrange point of Jupiter's orbit, the other on the other side. Are we going to visit both?
Yes, Ron. There's the one side is the Trojan side and one side is the Greek side. And normally the asteroids are named after from the Iliad and the Odyssey. They're named after either the Trojans or the Greeks. But in the case of Patroclus and Menetius, I think they're on the wrong side. So they're like spies.
That's exactly it. That's exactly it.
Wow.
These are the one, as you stated earlier, these are the trailing pieces. So they might have been with the original grouping, and now they're the Spy Kids asteroids on the other side.
Huh. I thought it was the Greeks that put up the Trojan horse. Aren't they the ones that attacked Troy?
Yep.
Okay, so they're both the same. Trojan was just the name of the horse. Greeks are a whole bunch.
Ron, the Greeks were attacking Troy, where the Trojans lived.
Okay, but the Trojan horse was theirs. They made it. They put it there, right? Filled with soldiers.
Yes, yes.
It suddenly became a literature discussion group.
It's called the Trojan horse because it sucked in the Trojans.
Look at this.
So this is from the Ralph camera. This is again from New Horizons. This is as close as they got to the image of the asteroid. I apologize. Help us basically, this gives us the organic molecules on board. So remember how we talked about the redness and the reddest asteroid that we were going to be visiting? This will help us be able to determine some of the composition of it, whether there's oxygen present or not, which turned it red.
Somehow those two rocks bonded, not only collided, they didn't break up, but they sort of glued.
Well, Ron, this is Aerocoth. This is the Kuiper Belt object that the New Horizons mission went by.
I understand.
These are icy bodies, and they're moving slowly relative to each other, so they stuck.
Okay, so they're not connected literally.
Yeah, they are.
Yeah, but it might be a very weak connection.
Yes, that's what I was about to highlight right here. As you can see the reflection, you can see the light through here. And so you can kind of see that reflective piece where it's not exactly a super strong connection towards blocking it out.
And this is a real picture.
Yes, this is a real picture.
Wow. Should call that the bowling pin asteroid.
So a perfect example is what it was used from the infrared spectrum. This is what it used when again, this is talking about Pluto's moon. Found ammonia ice concentration. This is the Luke Skywalker crater and the Organa crater. This will help us more for our fundamental questions of, is there water, oxygen, life-sustaining materials present in these asteroids? And this is how they did it with Pluto's Charon. And so this is where I can kind of leverage a little bit from my field, from the infrared side of it, is that what it does is when it points this camera at the surface of any material or any object, it looks for the spectral response and basically the wavelength spike that the materials give off. And every material, no matter what, anywhere it is in the world, gives off the exact same signature, which makes it quite interesting from the infrared side. So they can always tell if it comes off, for example, for water and ice is about 2.5 microns to 3-ish microns, depending on how concentrated the ice is. No matter where you are, it'll always give off that type of spectral spike. So it'll be able to determine to basically a 90% to 99% accuracy that is exactly going to be ice or water if they're staring at it through the infrared material.
Huh.
Right.
Ammonia ice. Well, that'd be awful stuff to deal with.
Yes. And then one of the last technology pieces, the LATIS, which is the infrared thermometer. This is just temperature gauging for how the asteroid is. Basically, it'll help us give a better idea and a more well-rounded composition understanding of these asteroids. As you see, it'll teach us about the surface, but it'll also give us the density understanding of it, depending on how much heat is trapped or escapes, composition materials, things of that nature.
Okay.
This is again reused from OSIRIS when it measured the Bennu asteroid.
So it's reusing established technology. The new thing about this is its travel path.
Travel path and the type of asteroids that are being visited.
Okay, yeah, right. Okay, good.
So here's our lovely scientist and project management team. As you can see, we have Dr. Hall Levinson, on the left here, he's also the principal investigator. We have Kathy Olkin, or I believe that's how you pronounce her last name. She's just one of the project managers as well. And then 2 engineers, Donna Bradshaw and one of the student engineers. And then some more of the student interns, like I was talking about from Lucy mission and the LaFam from the student intern side from ASU. And this is kind of the stamped photo of all the representation of where they came from. So NASA Goddard Flight Center, SWIRI, which is also has a big hub up in Boulder, Colorado at the university, Lockheed Martin. Not quite familiar with APL, but then you have
Applied Physics
ASU.
Laboratory.
I'm sorry?
They're in Washington,
Applied
right?
Physics Laboratory.
Yes, thank you.
And Arizona State University.
Yes, and ASU. ASU is become a big hub for a lot of like the NASA internships, especially associated with Lucy.
Mhm.
And where are they working out of? JPL?
Some of it's all over the place. Some's JPL, some of them, believe it or not, are remote. So it's a little bit of both, but most of it's JPL and NASA Goddard Flight Center.
Well, on my screen, our headshots are covering most of the student interns.
You can change that, Ron. So you just look at the speaker. You view in the upper right-hand corner.
Oh. Oh, yeah. Okay.
Yeah.
Click on that. Standard, side by side, side by side. Mm. Ah, thank you for that. There you are.
You're welcome.
You're not in that. You're not in that shot, Levi, right?
No, I am not.
Okay.
These were the ones that are the brains behind it. I technically will call myself a tag along because I joined the mission in progress.
Well, are you or any of the other guys going to be out trying to see that sucker come by us on the 16th?
At
You
4 in the
bet.
morning.
You
What?
bet. I'll be up at 4 o'clock in the morning. I'm just trying to figure out where we want to be to see it.
Jerry, what did you say?
Oh no, I just said repeating to myself 4 in the morning.
Well,
So that's, we have,
then.
I can predict that we will have a heavy marine layer at that time.
I was thinking the same thing.
My guess is I'm probably going to go up towards Lizard Mouth up that way
Yeah,
to get above the marine layer.
Actually, better is East Camino Cielo. There's a spot where we set up telescopes. It's a high point that's higher than the Lizard's Mouth area.
Okay.
Right.
Bruce
It's about
goes,
2.5 miles from the where Camino Cielo joins whatever they call the road.
San Marcos Pass Road.
Yeah,
Oh,
right.
okay.
well, Tom Whittemore, are
It's
you
actually,
still,
it's about 2.5 miles from where Painted Cave Road takes off from Camino Cielo.
so you're going to be out there, Bruce?
Probably, yeah.
How about Tom Whittemore? He gets up early, right?
Yep, I'll look for it here.
And you use binocs, don't you?
Always, yeah.
You can track with a binocular, but can you track with a telescope as it moves?
This thing should be bright enough to see through binoculars, you said, so.
Yeah,
It's
if
gonna
it's
be
moving
very,
that
very bright.
fast, if it's moving that fast, you can't get your eyeball on a telescope eyepiece anyway. So you're going to want a camera on your telescope and a fast set of motors.
Yeah, it's gonna be moving.
Takes a special drive mount to follow a satellite.
Called an expensive mount.
Well, gentlemen, we ate up most of the hour, but listen, we got 10 minutes to talk about DART. If you'd like to stick around with us, Levi Parillo, very well done presentation.
Yeah, thank you very much.
Sure.
Thank you.
We lucked out. We're going to have more shows like this on Monday mornings.
Sure.
If you'd like to, who wants to talk about, or you want to throw the cartoons up first to get a little levity in, as long as they were sent to us, Jerry? Because
sure.
there was a sudden flurry of silly cartoons immediately after, when did it crash into the asteroid? The 26th, I believe, of September, which would have been about a week ago. And I'll try to match anything you can call up, because some of them are darn funny. Here we go. These are silly science cartoons forwarded to us.
I like that one.
This guy, yeah, on the screen. NASA successfully hits the asteroid 7 million miles away, and he can't hit the wastebasket with a wadded up paper. All right. This guy's been waiting for a moment for a long time.
I didn't see that one. That's cute.
Yeah.
His tip is pie.
Yeah, 3.141592, yeah.
Okay.
And there was a further down on that same receipt, there was a comment that somebody made saying he can't do math. Pi is only 2.14.
Yeah. I took that off. That was too much.
And here we have a very bully-like Earth going, yeah, that's right. Who else wants some? I'm looking at you, 99942 Apophis. That's, I assume, another asteroid.
So this is the one we just hit.
Oh, that's the one we hit?
Yeah.
Close to us. All right. Oh, look, one of those cute little rovers that takes pictures is coming right at us.
Yeah.
Amazing.
Well-
And here's some, oh, I like this one. Scientist Hell. I wrote this one down. Let's see if I can find it. Scientist Hell. Where is it? Oh, psychics, astrologists, mediums, eternal discussion group underway inside this room where a scientist is being put. You should have read Chuck McPartland's response to an attempt to get some, what, our telescopes lined up next to astrologers somewhere recently?
Oh,
It's a Hollywood astrologer that was having a gathering out by Carrizo or by Kuyama, and they wanted telescopes and astronomers.
And what did you write?
I basically said we didn't want to give a shred of credibility to fraudulent practices.
Touche. All right. Oh, here's a bunch of extraterrestrials hovering in an what do they call now? UPAs? UFO. Come on, guys. We're wasting the laser beam battery trying to hit those damn cats.
not trying to hit it. They're getting the cats to chase it.
To chase it.
Cats will chase laser spots forever.
Oh, they're having fun. I see. You're
Yeah.
right. And tonight, NASA successfully hurled a projectile into an asteroid 7 million miles away at 14,000 miles per hour. Repeat after me. Meep, meep.
Wiley, what was that? Wiley Coyote?
Wiley Coyote, yeah.
Oh, this one I didn't see. Oh, wait a minute. Oh, somebody's on one of the asteroid they hit. I'm sure you remember the name of it. Uh-oh.
This is from a children's book called The Little Prince, and he lives on an asteroid.
Well, they sure designed those probes differently. The staggered opposite.
Okay,
There we go.
that's it.
All right, now we got 5 minutes to talk about whatever. Who wants to lead on this? Because I don't have any notes. I know we were successful.
Well, let me see if I can find the
video of coming in close.
not the video, but the let's see, where is that?
It says the Little Princess asteroid was known as B612.
It's a
And
great
there's
book.
the B612 Foundation that's out there now currently advocating for looking for near-Earth asteroids.
Ah, okay.
This was a picture taken by the Luisi, whatever it is, CubeSat that was let off of the DART satellite before the DART hit. And this is the splatter from DART hitting the moon of this asteroid.
Wow.
And there's quite a spectacular scattering of particles. And to my mind, that means that the energy of impact, which they were hoping would push the asteroid moon, change its orbit, went into creating this splatter zone of stuff. So I'm not looking for a major 100% transmission of the kinetic energy of the impactor into the moon's change.
You might get 200% because the stuff that gets shot off goes in the other way, and it actually adds to the momentum.
Well, is the explosion the upper?
That doesn't feel right to me, but you might be right.
That's all part of, study billiard ball collisions.
But this isn't a collision and a rebound.
Yeah.
This is stuff being projected off.
Yeah, if the satellite had rebounded this way by the same speed, then the target would move forward with twice the energy.
But how do you differentiate between the satellite rebounding and all the junk that it shot off rebounding? It's still momentum.
It's not a rebound. The satellite was completely destroyed and absorbed by the target, I'm assuming. So anyway, we can talk about that offline.
Okay.
Now let's see if I can get, we have another, oh yeah, these are, let's sequence of 4. The one I just showed you was this one up there. This one. It's hard to control this. Okay. So these are different pictures from the CubeSat, I assume, as the debris is shot off, starting from up here, going down there, and then down here. I don't know the time sequence between these, but the original movie that the DART made when it came in for landing was sending back frames 1 per second. This one is significantly slower. Maybe they did take it at 1 per second, but the data rate coming back to the Earth, because it was lower priority, it had a much lower data rate coming back, so the pictures didn't arrive here as fast. But I think they may still be taken 1 second apart.
Yeah, and Jim Williams is asking if the results of the DART impact have been made public yet, and we don't know yet because it's going to take at least a week and probably a month of monitoring Dimorphos to see how its orbit has changed. And they're going to do that both with photometric, because it's in effect an eclipsing binary right now to measure its orbital period. Plus, there's a whole campaign of occultations being done. A lot of them are going over Australia. So it's the Australian folks in IOTA doing a lot of the occultations to try to get the new timing.
Huh. Levi Parillo, do you have anything you'd like to add? Are you still with us?
Are you muted?
No.
Levi, we've lost Levi. He's left the building. My understanding was that there were 2 parts. Oh, hi.
Now.
I'm here somewhere.
Yeah. Okay.
Levi, do you have any comment you want to make on the DART mission?
Didn't really have much to speak on with DART, as you know, most of you have alluded to. It's going to be a little bit before they confirm it. But I did have 2 things real quick I wanted to give up with the Lucy mission just before I forgot. Was one, there's actually an album that you can listen to for the sounds of the mission. So there's actually a NASA Lucy mission soundscape. So if you go to nasa.gov/Lucy-soundscape, it is a collection of music all over the world from different composers that they believe sum up and identify with the Lucy mission.
Okay.
Is there going to be a spot where we can get an ephemeris or a plot of where in the sky Lucy will be visible as it makes a close approach?
Yes, I'm actually currently trying to get that right now from one of the ladies who runs this from Sweary up in Boulder. So I'm working on her to get that. I think they have something. If they do, I'll pull it down immediately and send it out to you guys.
Yeah, thanks. We appreciate that.
I think
Tim Crawford had a question.
How will the Lucy mission change or assist future missions? Well, that's part of the big question, is because it's all about what they find. What do we find with these asteroids will dictate a lot of our future missions, especially the composition. If we find, for example, let's say Jupiter has more inhabitable material than Mars does. What are we going to make a decision about that with regarding possibility of life looking into Jupiter as well? I know the composition of Jupiter is not sustainable, but there could be clues that there's something else or something along those lines that correlate with it. But a lot of it's going to give us an answer of kind of why the universe and these planets are formed the way there is. Why are they so kind of perfect between, you got solid ones, then you got the gas ones, and then you got the chunk of ice with Pluto way out there. So it's going to answer a lot of our burning questions that we've had since we began studying the solar system about why are they that composition? Why are they all rock? Why are they only this? Why do they get cut off after a certain distance from the sun? Why does their composition change? So it's going to answer a lot of the fundamental questions that they have.
Well, Levi Parillo, you were a hit. You did good, but we're not going to quit until we get you into the club, my friend. I got to tell you.
Excellent talk, very informative.
Yeah, and you'll probably be around living in this area and available perhaps in the future, next flyby of our planet.
Currently, that is the plan. I live up in Goleta, right outside Santa Barbara, so pretty close by.
This coming Friday night is our general meeting. It's always on the first Friday of a month, and it'll be the 7th of October. And Dr. Claudio Campagnari who runs the physics department out at UCSB, is probably going to be talking about the CERN Hadron Collider and some quantum physics stuff.
Oh, wow.
And
Okay.
a month later from that, there's another UCLA grad student who's going to take us deep into the interior, the center of the galaxy of the Milky Way. Jeds, we didn't get to talk about Helix Nebula, a dying star, but maybe next week. Mercury's our morning star for now. First quarter moon will probably be half moon.
Full moon by then.
Yeah, full moon. It's in Sagittarius right now. And with we'll talk about the variable star of the month next week, Mira, and get more updates. Maybe Artemis will be launched. Thank you again, Levi, for contacting us. Keep it in touch. And the rest of you, take care of yourselves and your wives, get all those shots. And we love you. And we'll see you back here next Monday for the 85th episode of the Santa Barbara Astronomical Unit Astro Hour. It's SBAU.
See you next week. Bye.
Thanks, everybody.
Thank you.